What's up guys, it's Simon Fiaz and today's video is on group 2 and group 7 elements. So, using flame test to identify group 2 ions, dip a nichrome wire loop in concentrated HCl, concentrated hydrochloric acid, dip the wire loop into unknown compound, dip a nichrome wire loop into concentrated hydrochloric acid, dip the wire loop into unknown compound, hold loop in clear blue part of to burn the flame, observe the color change in the flame. If it's a calcium Ca2 plus ion, brick red, Sr2 plus ion, red, Ba2 plus ion, pale green, and that's the flame. Those are the flame colors. Using dilute sodium hydroxide solution to identify group 2 ions. Add sodium hydroxide dropwise to a test tube containing the metal ion solution and observe the precipitate formed. Keep adding sodium hydroxide until there's an excess. Record any observation or changes that you might see. Mg2 plus Ca2 plus Sr2 plus Ba2 plus. With OH minus, Mg2 plus slight white precipitate with excess OH minus ions white precipitate. Ca2 plus slight white precipitate with excess OH minus ions slight white precipitate. Sr2 plus with OH minus slight white precipitate with excess OH minus still slight white precipitate, and Ba2 plus no change with OH minus and no change with excess OH minus. Hydrochloric acid is added to remove any traces of carbonate ions as they will produce a precipitate as well and therefore disrupt the results. I think that's not relevant to this. Yeah, but to remove any trace of carbonate ions. Test for halide ions. Add dilute nitric acid to remove ions which might interfere with the test. Add a few drops of silver nitrate solution. Add a precipitate formed with a silver halide. If it's F minus, fluoride, no precipitates, chloride, white precipitate, bromide, cream precipitate, iodide, yellow precipitate. Now you can see here F minus no precipitate, Cl minus white precipitate, Br minus cream precipitate, I minus yellow precipitate, and Cl minus forms the slowest and I minus yellow precipitate forms the fastest. To be extra sure, each silver halide has a different solubility in ammonia, so therefore we add ammonia. And Cl minus white precipitate dissolves in dilute NH3 aqueous. Br minus cream precipitate dissolves in concentrated NH3 aqueous. I minus yellow precipitate insoluble in concentrated NH3 aqueous. Least soluble to most soluble. Now these reactions. NaI solid plus H2SO4 liquid from NaHSO4 solid plus HI gaseous, 2HI gaseous plus H2SO4 liquid from I2 solid plus I2 solid plus SO2 gaseous plus 2H2O liquid. Then 6HI gaseous plus SO2 gaseous from H2S solid, H2S gaseous plus 3I2 solid plus 2H2O liquid. So this one's pretty easy. It's these two that I struggle with memorizing, and maybe you guys do as well. So let's go through it again. 2HI gaseous plus H2SO4 liquid to form SO2 gaseous plus I2 solid plus 2H2O liquid. Then 6HI gaseous plus SO2 gaseous to form H2S gaseous plus 3I2 solid plus 2H2O liquid. Then NaBr solid plus H2SO4 liquid from NaHSO4 solid plus HBr gaseous. Then 2HBr gaseous plus H2SO4 liquid from Br2 gaseous plus SO2 gaseous plus 2H2O liquid. So 2HI plus H2SO4 and this. The only difference is in this one I'm forming Br2 and this one forming I2. So those are the same. It's this bit very difficult to learn. 6HI gaseous plus H2SO4. 6HI gaseous plus SO2 gaseous to form Br2 gaseous plus H2S gaseous plus 6HI gaseous plus SO2 gaseous to form I2 gaseous. No. 6HI gaseous plus SO2 gaseous to form 3I2 gaseous, 3I2 solid plus H2S gaseous plus 2H2O liquid. 6HI gaseous plus SO2 gaseous to form 3I2 solid plus H2S gaseous plus 2H2O liquid. This reaction gives misty fumes of HBr and also produces choking fumes of SO2 and plus orange fumes of Br2, and that's after 2HBr plus H2SO4 to form the Br2 plus SO2 plus 2H2O. And this one, NaF solid plus H2SO4 liquid, NaHSO4 solid plus HF gaseous, NaCl solid plus H2SO4 liquid from NaHSO4 solid plus HCl gaseous, misty fumes as gas comes into contact with moisture in the air. What happens in order to reduce something? Halide ion needs to lose an electron from the outer shell, losing attraction. So two things that happen to halide ions are in the group. Ions get bigger, so electrons are further away from the positive nucleus. Extra inner electron shells, so a greater shielding effect. Ions get bigger, so electrons further away from the positive nucleus. Extra inner electron shells, so greater shielding effect. Cl2 gases plus H2O liquid form arrow 2H plus aqueous plus Cl minus aqueous plus ClO minus aqueous. 2 Cl2 gases plus 2 H2O liquid arrow 4H plus aqueous plus 4Cl minus aqueous plus O2 gases. Cl2 plus H2O liquid gases liquid 2H plus aqueous plus 2Cl plus Cl minus aqueous plus ClO minus aqueous. Cl2 gases plus H2O liquid 2H plus aqueous plus Cl minus aqueous plus ClO minus aqueous 2Cl2 plus 2H2O 4H plus aqueous plus 4Cl minus aqueous plus O2 gases. Sodium hydroxide, chlorine 2NaOH aqueous plus Cl2 gases to form NaClO aqueous plus NaCl aqueous plus H2O liquid. Sodium chloride 1 solution, bleach use, aka bleach uses, water treatment, bleach paper and textiles, cleaning the toilet. Reducing power. Reducing power of halides increases down the group. Why does the reducing power of halides increase down the group? Easier to lose electrons, greater reactivity. Halogens become less oxidizing down the group. Halogens will displace a halide from a solution of halides below in the periodic table. Cl2 aqueous plus 2Br minus aqueous to form 2Cl minus aqueous plus Br2 aqueous. Cl2 aqueous plus 2I minus aqueous to form 2Cl minus aqueous plus I2 aqueous. Br2 aqueous plus 2I minus aqueous to form 2Br minus aqueous plus I2 aqueous. Add chlorine colorless. Add bromine aqueous, so bromine water, chlorine water colorless, bromine water orange, iodine water brown. KCl aqueous colorless, KBr aqueous colorless, Ki aqueous colorless. No reaction. Orange solution Br2 formed, brown solution I2 formed. No reaction, no reaction. Brown solution I2 formed, iodine formed. No reaction, no reaction, no reaction. F2 fluorine pale yellow as a gas, chlorine green, color is green as a gas. Br2 it should say Br2 red dash brown as a liquid, I2 grey, and it is a solid. Why does electronegativity decrease down the group? Well, larger atoms, therefore they attract electrons less than smaller ones, as the electrons are further away from the nucleus and are shielded by more electrons. Wet scrubbing is when acidic sulfur dioxide can be removed from flue gases by reacting it with an alkali. Slurry is made how? By mixing calcium CaO, calcium oxide or calcium carbonate with water, and then it's sprayed onto flue gases, and what happens is the silicon dioxide reacts with alkaline slurry, forming calcium sulfide. CaO solid plus 2H2O liquid plus SO2 gases to form CaSO3 solid plus 2H2O liquid. CaCO3 solid plus 2H2O liquid plus SO2 gases to form CaSO3 solid plus 2H2O liquid plus CO2 gases. Magnesium is used in reduction of titanium. TiCO4 gaseous plus 2 mg solid. TiCO4 gaseous plus 2 mg liquid to form Ti solid plus 2 mg Cl2 liquid. TiCl4 gaseous plus 2 mg liquid to form Ti solid plus 2 mg Cl2 liquid. X-rays, they're good for bones, broken bones, to identify them, but however they pass straight through soft tissues. Therefore, barium sulfate, which is opaque to X-rays, is used in barium meals to diagnose problems with the stomach, esophagus, etc., etc. Barium sulfate is opaque to X-rays. Therefore, using barium meals to identify problems with the stomach. What happens is the patient swallows a barium meal, which is a suspension of barium sulfate, which coats the tissues, making them show up on the X-rays, therefore showing the structure of organs. Calcium hydroxide, aka slaked lime, is used in agriculture to neutralize acid soils. Magnesium hydroxide, used in indigestion tablets as an antacid, a substance which neutralizes excess stomach acid. And magnesium hydroxide is considered to be sparingly soluble. Therefore, what it means is it has very, very low solubilities, Test for sulfate ions. Acidified barium chloride solution added to a solution acidified barium chloride solution added to a solution containing sulfate ions, then a white precipitate barium sulfate is formed. And here I've got magnesium, calcium, Sr, Br, Ba, OH minus, SO4 2 minus. I can see that increase in solubility down the group, decreases in solubility here. Group 2 hydroxides / sulfates are all white when solid. Group 2 hydroxides / sulfates all white when solid. Now, key fact about compounds of group 2 elements. Compounds of group 2 elements containing OH minus ions. What I should have said is compounds of group 2 elements containing singly charged negative ions. So just one negative ion charge, increase in solubility down the group, whereas compound of group 2 elements containing doubly charged negative ions, SO4 2 minus, decrease in solubility down the group. Now, obviously, these are two most common ones: a singly charged negative ion and a doubly charged negatively ion. So compounds of containing OH minus ions, the increased solubility down the group. Compounds of like SO4 2 minus, decreased solubility down the group. And group 2 hydroxides or sulfates are all white when solid. M solid plus 2H4 liquid form M bracket OH squared aqueous plus H2 gaseous. M solid plus 2H4 liquid form M bracket OH squared aqueous plus H2 gaseous. And this is for M represents any group 2 element. When group 2 elements react with water, they oxidize from 0 to +2, and water is an oxidizing agent in this reaction of M solid plus 2H4 liquid form M bracket OH squared aqueous plus H2 gaseous. Water is an oxidizing agent.